right, as we get started, let's go and review what we talked about yesterday. We began looking at angles on the Cartesian plane, angles in standard position, meaning the vertex class is at the origin, meaning the initial side is on the positive x-axis, and then the terminal side goes wherever, through some random point, I don't know, call it xy, right? And if I wanted to find the trig ratios of this angle theta formed by this line that goes through this random point, the problem is in order to find trig ratios, you need opposites and adjacents and hypotenuses and stuff like that, right? So I would have to make a triangle. How do I make a triangle, Chris?
You draw a straight line down from the point, right?
Draw a straight line down from the point. Straight down to the x-axis. Never across to the y-axis, but down to the x-axis. We call this our reference triangle because we're drawing this triangle for reference, right? And so the length of this line will always simply be equal, class, to the y value. And the length of this leg will always simply be equal to the x value. And then we gave what letter to this hypotenuse, this line from the point to the origin, class?
R.
R, for radius, if you will. And we said that x could be positive or negative, y could be positive or negative, but R, class, is always positive. How do I find R, Ethan?
Pythagorean Theorem.
Pythagorean Theorem. And we go from there, right? We would say then that the sine of theta, well, sine's what over what, class? So on the Cartesian plane, the sine is what over what?
Y over R.
Y over R. You don't necessarily have to memorize it. That's a good way to think it through. Cosine's always what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse, but on the Cartesian plane, x over R. And then the tangent of theta is always what over what? Opposite over adjacent. So on the Cartesian plane, y over x. However, not all angles are in the first quadrant, right? You could have a quadrant 2 angle. So we said that if the angle happens to drift, for instance, here into the second quadrant, here's my theta. Well, I still draw the reference triangle the same way. Class, by simply drawing a line straight down to the x-axis. So that this is still y, this is still x, this is still r, but one of these is now negative.
The Y. No, the X.
The x, right? X is a negative value here. Maybe it's like -3. Well, y is something like 7. I don't know, right? But x has to be negative in the second quadrant. So because of that, anything that involves an x will also become negative. Cosine will be negative. Tangent will be negative. Their reciprocals will be negative. So really, the only thing that's positive, class, is the thing that doesn't have x, and that would be the sine. Or, of course, its reciprocal, cosecant. So sine and cosecant are still positive. Everything else becomes negative. In the first quadrant, everything's positive, right? Because x is positive, y is positive, all of that. Well, we move to the third quadrant, right? And now we're dealing with some kind of a reflex angle. How do I draw the reference triangle? Straight up to the x-axis. But it always goes to the x-axis. So here's my reference triangle. Here's x, here's y, here's r, but what's negative?
Y. And R.
Never R. R is always positive.
Yeah.
And x. Right, you're going backward x, downward y, something like, I don't know, -6, -3, I don't know. But both x and y will be negative here in the third quadrant, won't they? So that now we would expect anything with x or y to be negative, but anything with x and y would have to be positive. So the tangent in the third quadrant gets to be positive, cotangent, its reciprocal is positive, but everything else ends up being negative, right? And then finally in the fourth quadrant, another reflex angle. How do I draw the reference triangle? Straight up to the x-axis. Always draw to the x-axis. And so again, here's x, here's y, here's r. What's negative? Only the y this time. So anything involving just a y as opposed to the x ends up being negative. Well, this has a y, it's negative. This has a y, it's negative. But what remains positive? Cosine. Doesn't have a y in it. So cosine, and of course its reciprocal secant, end up being positive values. To remember what happens in what quadrant, I gave you 4 letters, class. ASTC. A stands for all, S stands for sine, T stands for tangent, and C stands for cosine, right? We get our three trig functions, our main trig functions, of course, all. But how do we remember the order of the letters? Y'all been trying to say it this whole time?
All students take calculus.
All students take calculus. If you remember that when you graduate from school, you've finished this class, you're ready for Calc 1 when you get to college, all students take calculus. You remember that quadrant 1, all trig functions positive. Quadrant 2, sine and the reciprocal positive. Quadrant 3, tangent and the reciprocal positive. Quadrant 4, cosine and the reciprocal positive. There's one more little detail though. Theta is an angle in the triangle. Theta is not in the triangle. So for quadrant 2, we not only need a reference triangle class, we actually need a reference angle, which we'll represent with the Greek letter rho. It looks like a little p, right? But we call it rho. And rho here and theta together complete a 180. So if I know theta, how would I find rho? Take the whole 180 that they make together minus whatever part of that theta is. Make sense? Looking here, this angle is in the triangle, but it's also way more than what's in the triangle, right? So here, this is my reference angle. Theta is the whole huge thing. How do I figure out what piece of theta is rho?
Minus 180.
Cut 180 degrees off. Good, Chris. So rho would be the whole theta minus 180 degrees. And then we come over here. Well, here's theta, massive angle. Here's rho. Together they complete 360. So if I knew theta and I wanted to find rho, I would simply 360 minus the theta. Take the whole 360 they make, minus the part of it that is theta, and that'll leave you with rho. That way you always wind up with an acute angle. And we discovered yesterday, we tested it on the calculator, right, that if you were to make up some random angle, and you were to take the rho, take the sine or the cosine or the tangent of them both, it always came out the same, except sometimes one was negative, one was positive. If the acute angle, the rho, would always come out positive. So we're going to use ASTC to account for when it should be negative. Let's take a look at your homework now, page 54, numbers 2, 4, 6, and 7, and see how you did finding the trig ratios of angles formed by lines going through these various points. You want to have that homework out, books open to page 54. And problem number 2, what was the point they gave us, Ethan?
Negative 15.8.
I'm sorry?
Negative 15.8.
Negative 15.8. So the first thing you had to do is draw a quick sketch on your paper. Find the point negative 15.8. What quadrant was that in?
It was in quadrant 2.
Good, because you're going to start at the origin, go backward 15, upward 8, and then draw a line back to the origin. This is your theta. We had to finish the reference triangle, though, by drawing the line straight down. So here we went up 8, we went back 15, and we have to find r using class the Pythagorean Theorem. Essentially, r is the square root of x squared plus y squared. X squared plus y squared, then take the square root. What is the length of the r value, class? 17. So again, although we're going to say theta, we're going to think rho, but we're going to account for the negative on the 15. So the sign of theta will be the same thing as the sign of rho, so long as I account for the negative. Sines what over what, class? Opposite over hypotenuse. So looking at the rho, what's opposite over hypotenuse?
8 over 7.
8 over 17. Which means, by the way, come down to the bottom, that the cosecant of theta must be 17 over 8. The cosine is what over what? Adjacent over hypotenuse. So looking at the rho, but we're going to say theta, what's adjacent over hypotenuse? Negative 15 over 17. And while we're at it, let's get the secant of theta. Negative 17 over 15. The tangent is what over what, class? Opposite over adjacent. Looking at the rho, what's the tangent of theta?
Negative 15 over 8.
Opposite over adjacent?
Oh,
8 over negative 15. Slide the negative out front. Negative 8 over 15. So therefore, what's the cotangent of theta, class?
Negative 15 over 8.
Negative 15 over 8. Notice everybody's negative except sine and cosecant. ASTC, we'd expect sine and cosecant to be positive here in the second quadrant. How many have these answers on number 2? Questions on number 2? Chris, I saw your hand a moment ago.
I did the wrong problem. I didn't know which range 7 and 2.
Okay, questions on number 2?
I think I just looked at 3. No, I think I would have got the right answer. I didn't sketch though. Is that going to be
The sketch is going to be really helpful unless you want to memorize y over r, x over r, and y over x. Like if you memorize that, you don't need to sketch. I got enough to memorize in life without memorizing x's and y's, so I prefer a quick, because it doesn't take long to draw the sketch. That way I can just continue to think opposite adjacent hypotenuse, frankly. But it's an option, right? And the book kind of pushes the x and the r and the y method. I show it and then I'm like, let's just think opposite adjacent hypotenuse. So yeah, that's my...
We're what?
Yeah. Lazy, exactly.
All
All right, lazy. It's what we all like, lazy. How about you lazy?
Yeah,
I'm Jamie.
I got it right, but except for sine and cosecant, I have both of them negative. I'm not sure why.
Right, well, do you see that neither opposite nor hypotenuse are negative? They're both positive, so it should come out positive. Make sense? Okay, good. All right, let's take a look at numero quattro. And the point here, -7, -24, falls in which quadrant, Jamie?
Quadrant 3.
Quadrant 3. We're going to go, I'm going to draw like this. We're going to go backward 7 and then downward 24. Something drastic like this.
Yeah, I just made it up on the Cartesian.
Theta is this whole thing, right? Okay, and we need to draw the reference triangle. How do we draw the reference triangle, class? Straight up to the x-axis. So here is rho. This line has what length, class? -24. This line, and then this line, we have to use the Pythagorean Theorem to get 25. All right, so we need the sine of theta, the cosine of theta, the tangent of theta, the cotangent of theta, the secant of theta, the cosecant of theta. I think I'm going to try to be smart and not erase this, so I don't have to keep rewriting that, because I am lazy. And so what do we get for the sine of theta here, Jamie?
-24/25.
Good, opposite over hypotenuse. Therefore, the cosecant
is -25/24.
What do we get for the cosine, Quentin?
-7/25.
-7/25. Therefore, the secant.
-25/7.
The tangent of theta, Chris.
-24/7, so positive 24/7.
Perfect. Initially negative over negative, but the cancel give you positive 24/7, therefore cotangent.
7/24.
And notice ASTC, we would expect tangent and cotangent to be the positives here, everything else negative. How many of these answers on numero quattro? Let's go to numero seis. Be smart, be smart. There we go. All right.
Now it's probably an OCD because that's just a perfect like.
It's okay. Consider yourself triggered. Number seis. We got 10, -24. What quadrant is that in, Chris?
So it'd be over 10, fourth quadrant.
Fourth quadrant. So we're going to go over 10, down 24, something like this. We're going to draw the line straight down. How long is this line, class?
24.
-24. How long is this line? 10. Here's my rho. Here's the theta. We don't really care about the theta. We're focused on the rho. We do need the hypotenuse, though. 26. All right, and we find the sine of theta, Chris.
The sine of theta is 10/26. No, I did that wrong.
Sine's what over what?
Opposite over hypotenuse on my paper. I just remember it's -24/26.
-24/26, which does reduce, by the way.
12/13.
-12/13. And once we've reduced it, let's go get the cosecant.
Reduction required?
Always.
Okay.
Always. Yep.
-13/12.
-13/12. The cosine, Ethan.
It is 5/14.
10/26 is we're going to reduce to 5/13.
Yeah.
I thought I heard 14. Did you say 13 or 14?
14.
Yeah. What's the secant, Ethan? Smart Alec.
13/5.
13/5. All right. For the tangent of theta, Jamie.
-24/10, which reduces to -12/5.
And therefore we get the cotangent.
-5/12.
And there we go. How many of these answers for numero seis?
Mostly, except.
Questiones? All right, most of them. All right, numero siete. We've got -9, -12. By the way, notice cosine and secant positive. ASTC, everything else negative. All right, and last one, number 7. -9, -12. According to what quadrant?
Third.
Alright, so we go backward 9, downward 12, something like this. There's the theta. Here's the rho. We draw our line straight up. This line, class, is
-12.
-12. This line,
-9.
-9. The hypotenuse we find to be
15.
15. By the way, if we want to be smart, Chris, I think, asked this once before. I think it was Chris. Said, could we just reduce these numbers directly on the triangle? Yeah, what comes out of all three numbers?
3.
We could have done the last one, right? 10, 24, 26, knock a 2 out of them all. Now, technically these are the numbers, but I'm going to think -3, -4, 5. Oh, there's our 3, 4, 5 triangle. Yeah, welcome back. All right, so for sine class, sine's what over what?
Opposite of hypotenuse.
So here we're going to get,
-4 over 5.
and while we're at it, let's get the cosecant.
-5
-5 fourths. Cosine, what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse, so here we're going to get
-3 over 5.
-3 over 5. Let's go and get the secant.
5 over 9.
-5
-5 over 3. Of course, the negative out front of the fraction. Tangent, what over what?
Adjacent over hypotenuse. Or
Ooh. Opposite over adjacent. TOA, right? So, -4 over -3. The negatives cancel. We get 4 over 3. So, cotangent
3 over 4.
3 over 4. Again, ASTC. We would expect tangent, cotangent to be positive. Everything else negative. Questions on this? Let's see. I was going to do 2 more. I feel like we've got this pretty well, though. So let's just do 1 more. Let's do number 9. Let's skip 5 for now, and let's just do number 9. Número 9. Oh, sí. Vámonos.
Buenos.
Number 9.
Number 9. What do we get for the R?
11.18.
Oh, we don't do that. We do exact values, don't we? Not these crazy decimals. So when we find the R, we're going to take the square root of x squared plus y squared. X squared gives us 25. Y squared gives us 100. Not negative 100, by the way. When you square a negative, you get the positive. So we end up taking the square root of 125, which, yeah, it's like 11.2-ish. But we can't do that. We need to reduce the radical here. How do I factor? Right, we're going to factor this into 25 times 5, where we take the square root of the 25 to get 5 times the square root of 5. Questions on the algebra we just did. So that's my R, 5 times the square root of 5. But, do you see we can reduce these numbers?
Could we have left it as just the square root
Cancel
of
the
25?
No, we always reduce. We always reduce fractions and ratios. We also always reduce radicals.
1 more than 2.
Right, we could take this and call it a 1, call this -2, and call this 1 square root of 5, or just square root of 5. Does that make sense? We always rationalize and we always reduce. Erased my list.
I finished the problem before you even reduced it. I was like,
So what do we get for the sine of theta, class?
-2
times square root of
5.
Right, -2 over square root of 5, which becomes -2 square root of 5 over 5. Now I'm going to leave this because that allows it to be easier to get the cosecant.
Just square root of 5 over 5.
Negative square root of 5 over 2.
Yep.
Easier to flip the unrationalized version. What about the cosine?
I square root of 5. Or square root of 5 over 5.
Initially 1 over square root of 5, that becomes the square root of 5 over 5, but this is easier to flip to get the secant.
Square root of 5.
Square root of 5 over 1 or just square root of 5. Then the tangent class, negative 2 over 1 or just negative 2, we flip that to get the cotangent. Negative 1/2. Notice everything's negative except cosine and secant. ASTC. Okay, questions on this? All right, let's drop down to number 13, and let's think through some things here. It says list the quadrants in which the given function is positive, and it says sine. Well, class, what quadrant, or in what quadrant, or quadrants, is sine positive?
2.
Quadrant 2 is sine's special quadrant, but also quadrant 1, because everything's positive in 1. So 1 and 2. For number 13, you just jot that down right there in your textbook. You don't have to do it on paper. Unless, of course, you're planning to save the textbook, keep it in pristine condition, and sell it on eBay at the end of the year. Number 14, the cosine. Where's that positive?
1 and 3.
Cosine,
No, 1 and
ASTC.
4,
1 and 4, right? 1 and 4. Cosine's positive. What about tangent?
1 and 3.
1 and 3. What about cotangent?
3.
1 and 3. Think tangent, go ASTC, quadrant 3. And of course, quadrant 1. Secant.
1 and 2.
No,
1 and 4.
1 and 4, because when we see secant, we think cosine, it's reciprocal. So 4, and then of course 1. What about cosecant?
1 and 2.
1 and 2, because again, cosecant goes with sine, which is quadrant 2, and of course, quadrant 1. Look over at the top of the next page. It says, identify the quadrant in which theta lies. Look at number 20. It says here that the tangent of theta is less than 0. What does less than 0 mean, class?
Negative.
Negative. So tangent is negative.
We can just make up a value, can't we?
What?
Can we just make up a value? Like if we wanted to, like to make it easier, like I know.
I don't think it'll make it easier. Thoughts, just stay with me here. And then it says sine of theta is greater than 0. Well, what does greater than 0 mean?
More than 0.
Positive. So we know that tangent is negative, and we know that sine is positive. Well, question. When would tangent be negative, but sine be positive? Quadrant 2. Sine's only positive in quadrants 1 and 2, right? But tangent's negative. That rules out quadrant 1. Here's another way you could approach the problem, making sure I'm on camera. I asked. Another way we could do this is just write out the acronym ASTC. When is tangent negative, class?
Sine equals
The S and C, the third, second, and fourth quadrants. Where is sine positive?
2.
1 and 2. So which quadrant are we in?
2.
Quadrant 2. A couple ways you could think that through. All right, let's take a look at number 22. Secant is greater than 0, class. What does that mean?
Positive.
Tangent's greater than 0. That means positive. When would secant and tangent both be positive?
Quadrant 1.
Could only be quadrant 1, right? Okay, secant's positive in 1 and 4. Tangent's positive in 1 and 3. That leaves quadrant 1 for your answer. Number 24. Tangent is less than 0. In other words,
Negative.
negative. Cosecant is less than 0. In other words,
Negative.
negative. When would both tangent and cosecant be negative?
1 and 2.
Well, let's think it through.
Or 1.
Tangent, negative. Cosecant, negative. Where is ASTC tangent negative, class?
It's S and C.
S and C, second and fourth. Cosecant. I don't think cosecant. It's not one of the big three. What do I think? Sine. When is sine negative?
Cosine and tangent.
T and C, 3 and 4. So what quadrant are we in? Quadrant 4. Do you see how to think these through? All right, look at numero 26. Cosecant's less than 0, or in other words, negative. When is, before we move on to the next one, when is cosecant negative? ASTC.
T and C.
T and C, third and fourth. Then it says cotangent's greater than 0. In other words, cotangent is positive, but I think not cotangent, but tangent. When's tangent positive? A and T, 1 and 3. So what quadrant are we in? Quadrant 3. Do you see how to think these through? Do the odds real quick, 19 to 27. Do the 19 to 27 odd. And thinking, and I just realized I think I went off camera for that last thing. That's what I was showing a minute ago. Sorry, YouTube audience. This is what happens when I have to be my own cameraman.
So I get
We should write a song about that. I am my own cameraman.
I get confused about the greater than and lesser than.
Okay, greater than 0 means positive.
but like,
Oh, which one's which?
yeah,
Okay.
I've always had a problem with that.
So if you see this, cotangent theta, this means less than, notice it's pointing to the 1, it's eating the 0. That means 0 is bigger, right? It's like if you were in the water, or there's this little minnow in the water. What does the alligator want? The alligator does not want the little minnow, he wants you. Because the minnow, he wouldn't even notice, he'd still be hungry. But if he could eat you, so it always is eating the greater. Since it's eating the 0, that means 0 is bigger than cotangent is, meaning cotangent is less than 0. Or you can just memorize this means less than, and this means greater than. But if it's eating the cotangent, that means the cotangent is the bigger thing. Cotangent is now bigger than 0.
I've always had a problem with that.
In fact, I've even got a little alligator mouth. So cool. Doing the odds, 19, 21, 23, 25, 27. Quentin's finished, Chris is finished, Jamie's finished.
What about the
All right, let's take a look at these. Number 19, what quadrant class?
4.
Quadrant 4. Number 21.
3?
Quadrant 3. Number 23.
3.
Quadrant 3. Number 25.
1.
Can't be 1 and 2, just 1. Cotangent is only positive in 1 and 3. Sine is only positive in 1 and 2. Therefore, it must be 1. And then number 27.
2.
Quadrant 2. How many went 5 for 5? Jamie?
4
Chris?
for 5.
Okay, Quentin 4 for 5? Sound like it? And then Ethan 4 for 5. Questions on these? Anyone you'd have talked through? Look at number 28. It says list the sign of each trigonometric function. We're not going to do these writing on paper. We'll do these together. But 120 degrees, what quadrant is that?
Quadrant 2.
Quadrant 2. Okay, so which trig functions would we get positives for?
Sine
Sine and
and cosecant.
cosecant. So everything else would be negative. Okay, number 29. What quadrant? 3. 255 falls in quadrant 3. Remember, 270 is the straight down, right? And it's not quite to 270, so it's still stuck in quadrant 3. Which functions would be positive? Tangent and cotangent. ASTC. Tangent and cotangent. Everything else is negative. Number 30. Picture this now. Negative 330 degrees. Quadrant 1. You go backward almost all the way around, right? And so I probably bring the camera over a little bit. Go almost all the way around backwards. So in quadrant 1, what are the signs going to be? All of them positive, right? What about negative 134 degrees? What quadrant, Chris? Third quadrant, right? Not backward all the way 180 yet, but backward past 90. Quadrant 3, what would we expect to be positive?
Tangent
And
cosecant.
no.
No, tangent and cotangent.
Tangent and cotangent. Everything else winds up being negative. Now let's look at number 33. What quadrant class?
4.
Quadrant 4. Negative 12 degrees would be in quadrant 4.
I was in there.
Yeah, number 33. We're skipping around a little bit now. Quadrant 4. And so what would we expect to be positive class?
Cosine and secant.
Cosine and secant. Everything else is negative. Negative pi over 6? Well, what is pi over 6, class?
30.
Welcome back, radians. 30 degrees, right? Negative 30 is in what quadrant?
1 or 4.
Quadrant 4, just like negative 12, right? Right before it. So, what's positive? Cosine and secant. Everything else is negative. Pi over 3 for number 35. What quadrant?
60 degrees.
60 degrees, so quadrant 1. What would you expect to be positive?
All.
Everything. Look at number 36. 5/6 of a pi. What I want you to do with radians is compare two things. 2 pies and 1 pi. Where does 5/6 of a pi fall? If you ate 5/6 of a pie, how much is that? A little less than 1, right? So 5/6 of a pie is going to fall somewhere around here, isn't it? A little less than a pie. Almost a pie, but not quite. So it obviously falls in quadrant 2. What would we expect to be positive?
Sine.
Stand up off to the side of your desk there, Chris. Sine and cosecant. It's reciprocal. Everything else has to be negative. Look at the next one. 7/4 of a pie. 7/4. Well, that's more than 1 pie, isn't it? In fact, 7/4 is almost 2 pies, right? 2 pies would be 8/4. So if it's almost 2 pies, that means it's nearing 2 pi. So we're obviously in quadrant 4, which means what's positive?
Cosine and secant.
Cosine and secant, positive, everything else negative. Negative 11 pi over 12. Negative 11/12. Now, 11/12 means almost 1, right? 11/12 is almost 1. We're going backward. You almost go backward all the way to a full pi. So almost backward pi puts us in quadrant 3, which means what's positive? Tangent and cotangent. Everything else? Negative. Number 39, negative 2/3 of a pi. Yes, sir?
Question, how did you know to go backwards instead of going?
Because it's negative angle. Negative angles go backward.
Yeah, that's the thing that I wasn't here for during.
Well, I recorded it on YouTube. Negative angles go backward.
Yeah, okay.
Yeah.
Because I remember I came back and got like yeah.
Mm-hmm. Now we know you didn't watch. All right, negative 2/3 of a pi, class. Where would that be?
Right, no, must be in third quadrant.
Backward. Now, not quite as like 11/12 is like if you divide a pie or a pizza into 12 pieces and eat 11 of them. That really is almost the whole thing. 2/3. It's still almost 1 though, right? It's more than half, isn't it? So it's backward more than half of a pie. A little bit more than that, somewhere right around here. Still in the third quadrant though, right? So what's positive? Tangent and cotangent. Everything else is negative. All right. Take a look at number 41. Take a look at 41. We are given that the cotangent of theta is negative 55 over 48, and we're told that the sine of theta is negative 48 over 73. They want us to list all the other trig ratios. So we know the sine, but we don't yet know the cosine, the tangent. We know the cotangent. We don't know the secant or the cosecant of theta.
We know all 3 values though.
But unlike past problems, we know all 3 values. We know cotangents, what over what, class?
Adjacent over opposite.
Adjacent over opposite. We know sines, what over what, class? Opposite over hypotenuse. So we know the opposite, the adjacent, and the hypotenuse all at once, don't we? We know something else. We know that sine is negative. Where is sine negative, class?
Sine is negative in
3 and 4. We also know that cotangent is negative. Where's cotangent negative?
2 and 4.
2 and 4. So what quadrant are we in?
4.
So as we list out our remaining trig ratios, I know that in quadrant 4, what will be positive?
Cosine and
But I know everything else will be negative. We haven't done that before. We haven't had to worry about what sine, S-I-G-N, sine, to put in front of our trig ratios. But otherwise, we've done this. Cosine's what over what? There's the adjacent. There's the hypotenuse. I get
55 over 73.
tangents what over what? Opposite over adjacent.
48 over 5.
But the negative that I wrote down a moment ago. Secant's what over what?
Secant is
Hypotenuse over adjacent. Or you could just say the reciprocal of cosine, couldn't you? Reciprocal of cosine. Well, here's cosine. What's secant? 73 over 55. What's cosecant?
opposite. 73 over 48.
Hypotenuse over opposite, or you could just say reciprocal of sine, so 73 over 48. See what we're doing here? Yes, sir.
So could you just play, instead of like figuring out which ones are going to be positive or which ones are going to be negative, could you kind of just go, I don't know if it's going to sound weird, go with the flow and just kind of figure out which ones are going to be positive?
Well, you know when you flip this one, it's going to have to be negative, right? And when you flip the cotangent, you know it's going to end up being negative.
So it kind of leaves you,
And it only leaves you two that are positive. Kind of maybe can get by with that, maybe not. Right? Let's take a look at number 43. We know that the cosine of theta is negative 36/85. We know that the cosecant of theta is negative 85/77. So what trig functions do we still need, class?
Sine.
Sine, theta, tangent, theta, cotangent, secant, and that's it, right? Now, two of these we can find just by taking reciprocals.
Sine.
Sine is
85 over 36, -85.
negative 77 over 85, reciprocal of cosecant. We can also find the secant.
Negative 85 over 36.
Negative 85 over 36. And at this point, going with Chris's point, we can kind of cheat the system and say we have 1, 2, 3, 4 negatives. There are no quadrants where everything's negative, right? There's a quadrant where everything's positive, class, that'd be quadrant 1, but every other quadrant, 2 at least, are positive, everything else negative. So since we got 4 negatives, that means these two have to be positive, which means we're obviously in what quadrant, class?
No, 3.
3, tangent and cotangent, quadrant 3. The other way you could have done it, I suppose, is right up front, get all the SIGNs. Well, cosine's negative, that means, if cosine is negative, that means we're either in quadrant 2 or 3. Can't be 1 or 4 because that's positive. Cosecant is also negative, that means either 3 or 4 to see, which means quadrant 3, hence positive. The important thing is just don't forget the SIGNs. Okay, don't miss out on those. And then tangents, what over what, class?
Adjacent over hypotenuse.
Opposite over adjacent. Cosine is what over what?
Adjacent over hypotenuse.
And cosecant's what over what?
Sorry. Opposite.
Hypotenuse over opposite. So tangent is opposite over adjacent, I should get.
77 over 36.
Cotangent would be the reciprocal.
36 over 37.
Okay. So the way I typically do it, I'll typically identify A, H, and O right off the bat. I'll typically figure the quadrant first, and then I can do it the way I'm used to. But if you wanted to take a shortcut, it may be a little bit of a shortcut for you. You've got that option while you do number 45. You do 45 there at your seats. I'm going to turn the air conditioning on because it's warm here. Making Chris sleepy. That's no good. We want Chris to fall asleep standing up, because then he would fall down, and then anyway.
Oh, I can't get up.
We're that poster up in Miss Morse's room about earthquakes.
That's kind of mental abuse.
I thought that's where Ethan was going. I was like, Ethan missed his cue. You never miss cues.
I thought about it. Some things you shouldn't say.
That's very true.
But you can count on Mr. Nadasky to say them anyway.
Yeah.
Oh,
I hate it here.
we love you, Chris. We do.
No, you don't.
We just have strange ways of showing it.
Miss Morse loved me. Actually, I don't even have any class with her. Same with Miss Morse.
She's been seeing a therapist to help her with her proof.
Me too.
Separation anxiety.
Yeah, even though I think she got over it though when I like almost broke the TV by tripping on the cords.
Oh.
Started to count, I was like 39, then 38, 37, I think it was about below.
All right, number 45. What quadrant are we in, class?
2.
Quadrant 2. So we know sine's positive. We know its reciprocal cosecant will be positive, and everything else is going to wind up being negative. Check your answers. For cosine, you should have had negative 60 over 109. For the cotangent, negative 60 over 91. For the secant, should have had negative 109 over 60. And for the cosecant, 109 over 91. Are we perfect on 45?
I messed up and I put cosecant with cotangent, that's the only thing I did. But I got the right numerical values.
Okay, so make sure we keep those straight then. Look down at number 49. number 49. Because frankly, to give you all the values is kind of insulting, right? You're like, I'm a senior, I don't need that help. So look at 49, where we're given the cotangent of theta is negative 4 over 3. This is more like what we were accustomed to from before, right? Where we're given two values, we're going to have to find the third. We know cotangent squared over what, class?
Adjacent over opposite.
Adjacent over opposite, and therefore we need to calculate the hypotenuse, or you might already know it. 5. It's a 3, 4, 5. And so the other thing we'll need to identify is what quadrant, but we need more information. So notice on 49, not only do they give us this, the cotangent is negative. Well, let's think about that. ASTC, what quadrants? S and C, second and fourth. But they also tell us that the sine of theta is something 0. What is this symbol, Ethan?
Greater than.
Less than.
0 is greater than.
Yeah, 0 is greater. So sine is less than 0. So this symbol means less than. And if sine is less than 0, that means sine is
Positive.
negative. Less than 0 is negative.
Yeah.
And if sine is negative, that means we're either in quadrants,
D and Z.
T or C, 3 or 4, which means evidently we are in quadrant
So 4.
4. All right, so when I list out my values, sine, cosine, tangent, I don't need to list cotangent, secant, cosecant, everything's going to be negative except class,
Except,
Cosine.
cosine and secant. Everything else negative. It happens to be negative, positive, negative, which is a nice little pattern there. And now we just fill in the gaps. Sine's what over what? Opposite over hypotenuse, so 3 over 5. Of course, with the negative in front that we wrote. But again, we took care of that up front, so we don't have to think about it now. Cosine's what over what?
Adjacent over opposite.
Adjacent over hypotenuse, so
Negative 3 over 4. Positive 3 over 5.
4 over 5. Tangent's what over what?
Opposite over adjacent.
Opposite over adjacent, so what is it?
3 over 4.
3 over 4. Secant's what over what?
Adjacent.
Hypotenuse over adjacent, the reciprocal of cosine, so 5 over 4. And cosecant's what over what?
Hypotenuse over opposite.
Hypotenuse over opposite, reciprocal of sine, so we get negative 5 over 3. Questions on what you're going to do on the next two problems?
Yeah.
All right, your seats, I want you to do numbers 51 and 53. 51 and 53. Just as before, you're given two values, find the third, but now you also have to deduce the quadrant so you can get the correct SIGN on every one of your ratios.
We're supposed to do,
All the remaining trig ratios.
right, but we're supposed to do Pythagorean Theorem to get the hypotenuse?
Unless you already have the hypotenuse. Like in this case, we already know the hypotenuse. We're missing the opposite. But we do use the Pythagorean Theorem
opposite, yeah.
to find the third side, more generally. On number 51, did you get the opposite to be 16? 16. Any questions on that? What quadrant do we have?
2.
Quadrant 2. Secant is negative in 2 and 3. Cosecant is greater than 0 or positive in 1 and 2. That gives us quadrant 2. So we should get sine positive, cosecant positive, everything else negative. Actually, I guess we didn't have to include secant. That's sorry, up there.
Most t squared by is writing out sine, cosine.
Isn't it though? Checking your answers on 51. Did you get them all correct?
Yes.
Move on to 53. Any questions, 51? Only one sum question. Twice sum question.
One thing I found that helped me, like when I figure out like what the missing value is, I write out A, O, and H, so then I can just kind of copy and paste them.
That's why I do this. I write the A, the O, and then the H. What did we get for the hypotenuse, class? 193. I like it when it comes out to an integer. Technically, that's a Pythagorean triplet, right? 95, 168, 193. I don't expect you to memorize it, though.
I'm gonna memorize it.
For quadrants, tangent, negative. Thoughts?
Well, then it can't be the third one.
Can't be the third one, or can't be the first
It has to
one.
be 2.
So if sine is greater than 0, in other words, Ethan's sine is
Positive.
positive, then that means it must be quadrant
2.
2. Okay. If we're dealing with quadrant 2, and that happened last time,
Yeah,
where sine and cosecant are positive and everything else is negative.
no variety.
I know.
So,
Disappointing.
I know.
Like me. Or Chris.
We know. Oh.
And check your answers here on number 53 once you finish. Good to go? Ethan, good to go? Jamie, not good to go. Question?
Yeah.
Quentin, good to go or question?
Question.
Which one? So if we do the bell for just a moment, question.
You have the tangent on.
Tangent, well, I skipped the tangent,
Okay.
I didn't recopy the tangent.
It's also over adjacent.
Yeah.
Oh, you're kidding me, I labeled it backwards.
I was about to say,
I
I was
screwed
like-
everything up.
I was like, I might be.
I was just seeing if you were paying attention.
I thought I was wrong, so I relabeled it in my book instead of got it all right.
I was like, I think that's wrong.
Tangent's opposite over adjacent,
I was
so make that a 95, make that the 168, make that, I got that right. Make that the 168, make that the 95. Yeah, these are the answers.
So I
here.
did get everything right.
Okay.
I was like,
I was like, I'm
right.
good, but that's not
Good
what I
job,
thought.
Quentin, for paying attention. I was hoping
No,
someone
I was
would
looking.
catch that.
I was looking at it. I was like, that's not right.
I wasn't gonna tell
How
you.
did I get wrong?
So the moral of the
So
story is
wrong.
don't be afraid to call it out when you see it, right?
I saw it. I was like, I don't know.
Especially when your math teacher has a small
I-
child in the house. I'm going to blame the small child for keeping me awake at night. But anyway, probably it's just because I'm human and I screw up things sometimes. But call out, yeah, you see error. This is true in politics, true in biblical doctrine, right? You see error, call it out, right? So yeah, next time call it out quicker, please. Help me out a little bit. I had a student realize something. One of my video students was watching and realized I messed something up and emailed me. I'm like, dang, I wish one of my students in the class had said something. So I had to put a little edit in the description. Just so you know, this was a mistake that nobody in the class caught.
Wait, is it our
So-
class?
No, it wasn't this class. No. But anyway, so yeah, help me out. You see mistakes, catch them, put them up. Isn't tangent opposite over adjacent, Mr. Nadowski? And that way, before I write all the answers and look really stupid, I can with a straight face say, good, I was seeing if anyone was paying attention. So anyway, y'all are dismissed. Have a wonderful rest of your day.
I will.